And now for the third and final section of Chapter 4, 4.3 on counting. So, suppose that you have two dice. They have 6 sides, 1, 2, 3, 4, 5, 6. How many possible outcomes are there? Well, we could do this the long way and write out all the possibilities. So it could be a 1 and a 1, so that adds up to 2. Imagine that one die is green and one is red. So maybe the green one has a 1 and the red one has a 2. Or it's the green one has a 2 and the red one has a 1. Anyway, when you do that, there's all the possibilities. So this would be if you get a 12, there's the 2 ways to get an 11, the 3 ways to get a 10, etc. So there's 36 ways possible. But do we really need to do it the long way like that? No. So since each side has 6 possibilities, and there's 2 dice, you just multiply 6 times 6 and you get 36. So we didn't actually have to do this table, although it was sort of fun for me to make. What about if you flip a coin? So the coin has 2 possibilities, heads, tails, and then you do that 8 times in a row. So you could go 2 times 2 times 2 times 2 times 2 times 2 until you've got 8 of them. Or you could shorten the work and just say 2 raised to the 8. So if you've got a TI-84, the raised to is this little arrow right here. So you would just go 2 and then raised to the 8. And it's 256. So is that the whole section? We just multiply? Well, imagine this. There's 10 kids in a race. How many first, second, third place finishes could there be? So at the beginning of the race, I don't know any of these kids. I don't know who's fastest, who's second fastest, and who's third fastest. So I'd have to look at all the possibilities. So as the kids are running, there's 10 of them in the race. So there's 10 possibilities for getting first place. Once that first person has finished crossed the finish line, there's no longer 10 people left, there's 9 people. And after the first and second place people are finished, then there's 8 kids trying to get third place. So it turns out that you do need to multiply, but in this case you can't repeat because you can't have the first person getting also second place and they also got third place. They need to be different people, so you need to count down. 10 times 9 times 8, which is 720 different possibilities. Oh, so on the homework, they would then ask a question like this. Find the probability, so it's the same setup. There's 10 kids in a race. Find the probability that the 3 tallest kids are the ones that finish first, second, and third. Well, first you'd have to do this part, 10 times 9 times 8. And if they are the 3 tallest, that's 1 possibility out of the 720. So then the probability would be 1 divided by 720. Now, what if you're not just concerned with first, second, and third, but you want to stay at the race and watch everybody finish? Well, if you repeated that experiment over and over again, how many possible finishes are there? Well, then we'd start like the last one, 10 times 9 times 8, but then we would need to keep going until the very last child finished. So when you multiply 10 times 9 times 8 times 7 times etc., that is 3,628,800. Now, instead of having to go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, you could also use factorial. So for factorial, you would need to go to math, move over to probability, and the exclamation mark, that's the 4th one down. So math, move over to prob for probability, and it's the 4th one down as factorial. Now there's just 2 more situations to consider. So in the last one I had 10 kids in a race, so that would be the end, 10 kids in a race. And I wanted to know first, second, and third, so that's a subgroup of size R. Now if the order matters, like with the kids in a race, then we use what's called permutations. So I could use the 10 times 9 times 8 like I just did, or I could use this formula. With permutations, you would put the bigger number here for n, so that would be 10 people in the race. And if you want to see first, second, and third, that means r is equal to a 3. So this would be 10 factorial divided by 10 minus 3 factorial, or in other words, it would be 10 factorial divided by 7 factorial. Now, if it's a situation where order does not matter, so for example, you've got 10 kids and 3 of them are going to volunteer to pick up trash after school, part of their community service. Well, for those 3 kids, there's not a first place, second place, third place. It's just 3 kids that are volunteering to pick up trash. So the order of those people does not matter. In that case, use combinations, which means that you've got this extra r factorial that you divide by. But don't worry, with these formulas, they're in the calculator. I'm going to show you how to do it. But first, when does order matter? Let's look at these situations. So just yes or no, does the order matter? Runners are chosen for a cross-country team. So it's not saying they're in a race. So if they're in a race, then first, second, and third matters. But if it's just a bunch of people that are going to go out and run cross-country, then there is no order. Order does not matter for that. 3 club members are chosen to work on a committee. So if they're working on a committee, it doesn't say there's a president, a vice president, and a treasurer. So it's just saying 3 people are working on a committee. Order does not matter. Then this one, 3 club members are chosen to be the president, vice president, and treasurer. So then it's implying an order. The president has the most power, the vice president, and then the treasurer. Next, what about answers to a 20 question, true, false? Hold on. That was not what I want you to do. Just stay there. Okay, not you, the Microsoft PowerPoint. Okay, answers to 20 question, true, false test. So if you're taking a test, do you have to put your answers in order? Yes. The answer to number 1 has to go with number 1. The answer to number 2 has to go with number 2. So the order does matter in that situation. So 11 full-time math teachers and 3 are going to serve on a hiring committee. So in other words, they read the applications and say, yes, we're going to interview this person, etc. How many such 3-person committees are possible? So with those 3 people, does the order matter? Well, if they're just going to go to a room and read applications, the order doesn't matter. No, the order does not matter. So that means that we can use combinations. So you could do the formula like I did right here, or you could use the calculator. So you would start with the bigger number 11, then go to math, move over to probability. So right there I'm using an older calculator, so it says PRB for probability. A newer calculator would say PROB for probability. And then, can you see it? It's number 3, NCR. So use number 3, and then you would type in the 3, hit enter, and there's the 165. So 15 horses are in a race. How many win place show tickets are there? So I was missing a comma, because that should say win, comma, place, comma, show. So that's just a fancy way to say win means first, place means second, show means third. So first, second, and third. So with that, yes, the order matters. So that means use permutations. And you could use this formula, or you could use the calculator. So you do need to put the bigger number first. There's 15 horses in a race. Then again, go to math, go over to probability, and it's going to be number 2, the NPR. And then you put the 3, and there's 2,730 total.